let's get some exposure to IPv6 addressing. IPv6 addresses, well, we've already maybe learned that they are 128 bits long and are represented in hexadecimal numbering schemes with a colon between every 16 bits. By the way, I like to call these quartets, these groups of 4 hex characters. It's a lot easier to refer to them that way, quartets. There's ways of shortening by dropping off leading zeros and using a double colon to represent a long space with a lot of zeros. This page isn't supposed to be talking about shortening, though, or the generic stuff. It's talking about address types. Global is the same as public. And an example on the screen indicates the first year that the public addresses were being handed out. And we're just being really conservative right now with the number of global addresses that we're handing out. Link local. This is a big deal to us. Link local is a self-assigned, unique address that can't be routed, but it allows us to chat on a LAN. It allows us to chat between us and anything else that isn't separated by a router. Why do we care? Because our IPv6 dynamic routing protocols speak using link local addresses. Multicast begin with FF, and it's baked into IPv6. Steve Deering is very happy. Steve Deering is the inventor of IPv4 multicasting, and probably wish that he had had his druthers with IPv4. But anyways, unique local. You can see an example here. Unique local is similar to private address, so to speak. Loopback. What is the IPv4 loopback address? Do you remember what that one is? IPv4 loopback is 127 dot anything. It's not just 001, it's anything. So we have the equivalent. Now this one looks a little funky, doesn't it? That basically says 32 or 31 zeros and a 1. Remember, 2 colons is the shortening technique. We can only use it once, and it represents a long space of contiguous zeros. Variable space. So we just have a 1. And then unspecified. Any idea why we would use unspecified? It does have relevance in this course. Let me write it a little bit differently. What if it said something like this? ::/0. What does that look like to you? Well, I'm going to write out the IPv4 equivalent, and maybe it'll make sense to you. Let's say I write out this. 0.0.0.0/0. What is that? Well, that's how we would write a default route in IPv4. So when we write a default route in IPv6, ::/0. And those are some of the most important address types for IPv6. And, you know, the key ones for us in this course are going to be link local, because routing protocols like to speak them. Multicast a little bit because, for instance, when OSPF communicates to designated routers or EIGRP speaks, it'll be to a multicast address. It'll be coming from a link local, going to multicast, and then unspecified. Basically saying, I'm going to write in a default route.